Greetings. In this video, I will present to you a research with the title Major Depressive Disorder Detection Using Effective Connectivity of EEG Signals and Deep Learning Transformer Model. MDD is more than just a term, it's a condition that deeply impacts a person's thoughts, feelings, behavior, and mood. Brain connectivity refers to the patterns and pathways of communication between different regions of the brain. In this research, we use effective connectivity. It able to provide different information on brain network dynamics, allowing researchers to determine whether brain areas have a causal link with other regions within a network. It also tells us the direction of the conversation. Now, let's move on with the methodology. Initially, 19-channel raw EEG data is collected from 30 MDD and 30 HC individuals. After the completion of data preprocessing, the EC analysis of the default mode network was carried by constructing a partial direct coherence matrix, which provided an insight into the connectivity patterns among all 19 channels across 64 different time bins. Then, the data, initially stored in a 3D matrix, is subsequently converted into a 2D matrix, which is more suitable for the input requirements of the VIT. The next step is to do data splitting. The training set was further split into a training, validation, and testing set using a random 80-10-10 split method. Next, each set will be trained in the pre-trained VIT base 16 model and using the tenfolds cross-validation method. Once the training, validation, and testing is done, we proceed with performance comparison of the pre-trained VIT-based 16 model via ROC curves and confusion matrix. The ability of the pre-trained VIT model to classify MDD and HC based on subject increment was analyzed. Based on the image, the model demonstrates high accuracy for the initial set of subject increments, which is from subject 1 to 2 until 1 to 11. However, the accuracy starts to constantly decrease when subject 12 is added and used for training and testing. The decreased accuracy observed with subject increments shows problems with the model's generalizability to additional subjects. Next, we also use images from 30 patients with major depressive disorder and 30 healthy controls. It achieved an accuracy of 82.17% in classifying MDD, with a positive predictive value of 73.82%. The model showed high sensitivity at 97.30%, but had a lower specificity of 68.24% for identifying healthy individuals. Overall, the model shows promising performance in classifying MDD. The model accurately identified 275 HC samples, but mistakenly labeled 128 HC samples as MDD. For MDD samples, 361 were correctly classified, while 10 were incorrectly identified as HC. The pre-trained VIT model, though resembling a random classifier in its ROC curve, achieved an AUC of 0.887. This near-ideal AUC value demonstrates the model's strong performance and potential as a diagnostic tool for identifying major depressive disorder. The pre-trained VIT model shows promising performance in classifying MDD and HC, as evidenced by its accuracy, PPV, sensitivity, specificity, confusion matrix, and AUC ROC. While the model may benefit from further optimization, this project demonstrates that transfer learning with VIT base 16 effectively captures complex EEG patterns for accurate MDD classification, offering potential advancements in MDD diagnosis and treatment.
Thank you for your attention.